Okay, let's start. We'll get some questions from the previous year question paper. Motion, force, momentum. On the website, basically, there is my save my exams. In this website, there are no questions related to projectile. So can we do some random questions? There is no option left. We also don't have any previous year papers available on the website. Do you have any websites at which we can find some previous year question papers? Don't have any idea? On Save My Exam, I cannot find. So let us start with some random questions. Okay. So yeah. Okay, so okay, let us start. So what's your name? Yes. Farhi, okay. Actually, Farhi, we were doing projectile motion. Okay. You have done it. Okay, you were in the class. Okay. So we started actually projectile motion. And Sohail said that sir, we are teaching this chapter in the exam. So that is why we started that. Okay. So no issue with this. Okay. I have taught the basic concepts of the projectile motion in the last class. In the today's class, we will bring some questions. Okay. On projectile motion. Okay. So yes. So the very first question that we have is an object is launched at an object is launched at. Okay, do you guys remember the three equations that I told you? Do you remember that? Okay, in the both absolute projectile and the half projectile, I have put some equations, right? Like for time of flight, I told you what? 2 u sine theta over g. Okay, for the h max, u square sine 2 theta or sine theta, u square sine theta, right? Sine square theta, u square sine square theta over 2g, right? And this is the u, normal u it is. And when you bring it here theta, it automatically becomes u sine theta, right? And u sine theta is the vertical component quantity. Okay, you will put the value of u here, and you will put the value of theta. That's it. Okay, and the range. For the formula for the range, it was u square sine 2 theta, correct? U square it was, yes, u square sine 2 theta over square or 2g. Is it sine square or sine theta square? Which word? Range. Sorry. H max is it sine square or sine theta? Sine square theta. How do you write sine square? See, you just simply evaluate sine theta first and then square. How do you do it? Just simply evaluate the sine theta first and then square root. Okay. So sine theta whole square it is. Okay, so you put the sine theta first, which is square. Okay, now an object is launched. An object is launched at a velocity. At a velocity. Okay, at a velocity of 20 meters per second. Of 20 meters per second in a direction. In a direction. In a direction. Making an angle of 25. Making an angle of 25 degree upward with the horizontal. Okay, upward with horizontal. Okay, horizontal. Right. So what we need to evaluate here, number A. Number A, what is the maximum height? Number A, maximum height you need to evaluate for this piece. Okay, number B. Number B, what is the time of flight? Okay, so after how much time? After how much time object will hit the ground? Will hit the ground. Okay, and option C, question number C, what is the horizontal range? Like horizontal range. Horizontal range. This you also should be evaluating. Okay, and last D, the magnitude of the velocity of the object just before it hits the ground. Okay, so last D, velocity of the object just before hitting ground. Okay, evaluate this and I will help you in this. Is it visible? The most important question is the last one. Okay, this kind of question can be asked. One more information I want to give you. I am teaching in the year 13 as well. So in some of the topics in the year 13, they are asking some application of projectile motion. Okay, so can we take those questions of year 13 in which projectile motion it is asking? What about Zoeb? Should not take those questions. Those are year 13, right? So okay, I won't choose that. Yes, please. 3.64 for what? A maximum. Are you sure, Zahid? Yes. Farheen? Same answer? Yeah. So for A, what option you got for A? What 3.64? 3.64 in what? Meter, kilometer, what? Meter. That's correct. For option B, for question B, 0.83 seconds. 1.72 seconds. That's correct. Mel, you got the same answer? Okay. Farheen? 1.72 seconds. That's good. Zohib? Same answer? Okay. C. Range? No. Evaluate it again. Range. Horizontal distance. Like how far it will reach. 31.2. That's it.
Wait, so what was the
31.2 meters. Height 1.72, right? No, 1.72 was the time, right? And the height, what did he told? Repeat it again. What the answer you got for height, maximum height? 3.64, yes. 3.64 meters. You got the same answer, Mel? See, simply use this formula, you'll get the direct answer. And if you don't want to use this formula, you have to do it all again, like using the equation. Do you want me to show like how to use the equation? Huh? Yes. So for the examination purposes, see these three things. How you will do? First of all, you will use three equations. Okay? By these equations, you will get these. Okay. After that, without using these formulas, you have to make the answer. Like in the question paper, you have to write it properly. By that, you can get the answer. You understand that? Well, see these equation, writing these equation won't get 2 marks. Okay. Mechanic. These equations won't award us any marks. Huh? Yeah, never use this. Okay. So by these equation, you can get the answer very quickly. Okay, you will know the answer. But now, after getting the answer, we have to verify that. Okay. So first of all, you will answer the first question. Okay. So maximum height. Okay. Maximum height. Okay. So number one, maximum h is this one, right? We had already discussed that. That if you want to attain the height, see, this is the projectile, right? This will go like this and fall somewhere else, right? And we want to evaluate this one. Okay, and we have three equations. What is that? V is equals to u plus 80. S is equals to ut plus half 80 square. And the third one is what? 2as is equals to v square minus u square. Okay, so in this way, in which the vertical component of the u is u sin theta, and the horizontal component of the velocity is what? U cos theta. You already know that. Yes. What answer we got for last one? Minus 8.4. Are you sure? We will do it later. Okay. I will tell you first. Let me answer one by one. How we will use the equation. Okay. So in that manner, initial velocity in the vertical direction. Initial velocity, u initial the vertical direction. U sin theta. And we will use u sin theta. 8.4. Okay, so now first of all, u initial we got what u sin. Okay, so in the vertical direction we will use this velocity only because the displacement is in what vertical direction. Okay, so u initial is this, and now for here to here, from here to here, from bottom to top, if you go, how much displacement you will travel? So displacement, I told you that it will be h max.
wait, sir, what's the height we got?
H max.
Yeah, what's the height?
3.64.
3.6.
3.6 or 3.6 itself. Okay. So H max we will do. Displacement is H max. Let's see. It is H only. Okay. And after that, acceleration. What is the acceleration you do? Minus G downward because in upward both are things are like positive. Okay. But the acceleration downward is negative. Okay. So U S A. And the final velocity at the top would be zero. We all know that whenever it will reach at the top, its velocity will be zero, right? So four data we have. We have a four data. Okay, which equation I will use to evaluate as if we have four these data? Third one definitely. So if the third equation is used, like you know that since 2as is equals to v square minus u square, then 2 multiplied by minus of a by minus g, and what is h max that we will evaluate? Okay, is equal to v became 0, right? And minus of u. What is u initial? It is u square sine square theta. All right. Now, what we will do? What we will do? We will put the value. Now, an object is launched at the velocity of 40 meters per second. So, in a vertical direction, and the g's value you all know that. G's value you all know that. What is the value of g? We will use 9.81. Minus and minus gets cancelled, right? So 2 multiplied by 9.81 multiplied by h is equals to u. What is the value of u? It is 20, right? So 20 square multiplied by sine theta. What is sine theta? Theta is 25 degree, right? So sine 25 and square. You understand that value? Okay. Now what happens? Now simply h. What is the value of h? So 20 square multiplied by what is sine 25 value? 0.42 and it's squared. Okay. Divide by what? 2 multiplied by 9.8. You understand that? Yeah. So simply these value we will put it here. Okay. And we will get the answer of h. What the h is what? 3.64. So h max you will get 3.64. You understand that? 8.4 I think. Let me check it again. Wait. What answer you got, Mikhail? Check it again. Check once again. Because if I say 8.4, like the velocity of the particle won't be like this much less.
So H max is
See, the height is getting like what 8.64 meter, right? And the particle is going like this, it would have two velocities, not a single velocity. In the horizontal direction as well, and the downward direction as well. So you have to add two velocities at the same time. You know that. And the velocity is what? A vector quantity. So you have to add both of the vector quantities at a single time to attain the last velocity. So 8.84, I thought that you have added both of the velocities, but it is the value of single velocity you are getting. You're understanding what I'm saying? Not understanding? Yes. See, how does it happen? See, let me explain you again. See, for question number D, I think 1, 2, 3 for you, 3 questions you are done, right? So for answer of D, I'm making you understand one more important thing. Let me rub this. Yes, please. 24.8. Still not near. Do you know that how to add vectors? The resultant vectors magnitude? Zohir? No? Okay, I'll explain you. Okay, but first of all, let me explain you that why do we have two velocities when the particle was falling? Okay, so let me rub this first. I have explained it already in the last class that when a projectile starts making motion, like if I say this is the horizon, okay, and this was the initial velocity u, okay, and this was the angle theta, right? And this particle is going like this in this direction. So I say that this is the vertical component, you all know that, and this is what u sine theta, right? And there is another component like this here, and this component is what? U cos theta, right? See, the u cos theta I have told you earlier that u cos theta does not change because there is no acceleration in the direction of horizon, right? There is no acceleration in the direction of horizon, only the acceleration in the direction of vertical. Because acceleration, gravitational acceleration, direction, acts in the direction of vertical. Okay, not in the direction of horizon. Yes, please. Okay, so when the particle reaches here, this u sin theta, because the acceleration is downward is right. So this u sin theta starts becoming small. Right? Because the negative acceleration downward, right? Due to this negative acceleration, this u sin theta becomes small. But you understanding that? You're getting it? Acceleration, if the acceleration is the negative, it will decrease the velocity. Understand that? And if the acceleration is positive, it will increase the velocity. You understand that? Since the acceleration is downward, that is minus g is downward, right? Minus g is downward, and the plus g is upward. Since it is minus g, that is downward, it will decrease this u sine theta, isn't it? Okay, but the u cos theta will remain the same. Okay, why? Because in the direction of u cos theta, there is no other acceleration. Right? So in that way, I will say that the resultant vector will be like this. Like this one. By merging both of them, this will be the resultant vector. Tell me. And when it reach here, again what happens? Again the acceleration works, and this u sin theta become more and more. Like initially it was like this. Now then it becomes like this. Now it becomes like this. This is again what? U sin theta. This is again what? U cos theta. Right? And now this is again what? U cos theta. Now if I merge both of them, if I find resultant vector of it of them, then this will be the resultant vector. Right? And at the top, at this height, we will say that the u sin theta becomes 0, the vertical velocity. Alright? If the vertical velocity becomes 0 at this point, then I will say that there is only one velocity at this point. And this one is like this. This one is what? U cos theta. Yes, please. 18.4. I will explain it. Wait, I will explain it. And as soon as it reaches here, now the downward acceleration will increase the velocity in the negative direction. So now at this point, I will say that here this velocity starts acting down, but this is same. So again, merging both of them, the resultant velocity will be here. Again, by reaching here, this increases. So again, merging them, you will go here. Again, if it increases, it will reach here. So if you say that right at this point, you will have two velocities. One velocity is downward and one velocity in this direction, right? Both of the velocities will be added. Do you know that how two vectors get added? Do you have any idea? See, we all know that if I have two vectors, like this is one vector that is A vector, and this is the second vector that is B vector. Both are co-initial, right? And if I say that these are at 90 degrees, if I say that they have certain angle between them, right? Then, and this is A vector, this is B vector. Then the resultant vector will be like this in this direction. Funny? See, let me make it again. The resultant vector again I will make. The resultant vector can be obtained like this. You will make a single same to same here also, and this will be the resultant. Alright? If this is the resultant, what is the value of resultant vector? So I told you that in the last class. In the last class, we had already discussed that how to find the resultant vectors in a game. Have we discussed it or not? Huh? You were not there. In the force, we discussed about that when the two forces are in circulation. Yes. The same. Parallel ground law. I have discussed it already. You were in the last class or not? You were there? Yes. So in that we added two forces. Force is also the vector. Do you want me to do it again? Mikhail? Only one, and you? What's your name? Mahim, do you want me to explain it again? No, you already know that. So what is the magnitude? Tell me. Yes, for this resultant vector, what is the magnitude? The angle between them is theta. Sorry? Is there anyone online? No, nobody's online. Nobody's online. Yeah. Tell me for this condition. If this is A vector, this is B vector, and there is an angle between them, this theta, then what will be the resultant magnitude? Funny, it is. Wait. Funny. Should I explain it again? Just be honest. I will explain it again. Don't worry. Should I explain it, Mahim? Yes. See, never say like that. I know that. If you don't know that, just tell me. I will explain it again. Calmly. Okay. Be clear. Okay. So now get rid of this in this part. And I will explain it again. For any vector quantities, you can apply this. Just wait, Zohair. Okay. For any two vector quantities, you can apply this. Okay. How can I do this? If I have a vector in this direction and another vector in this direction, and there is an angle between them, then there are two vectors here. Okay. Let's say this is A vector, and let's say this is B vector. Okay. Any two vector and vector, this formula that I am going to tell you here, it applies on every other form. Okay, every two vectors can be added up by that formula that I'm going to derive. Okay, so if this is two vectors, then I can say that by making a parallelogram like this, isn't it? Right? If this is B, the same direction I made this also. In the same direction I made this also. So this is also the B vector. And the same magnitude and the same direction I made here also. So this is also the A. So by connecting this to this point, and this will be the resultant. This is the resultant vector. Mikhail, this is the resultant vector. Okay. So this is resultant vectors. Okay. And now I want to evaluate what is the value of this resultant vector. How can I evaluate this? If both A and B are at theta angle, right? Then I told you that we have to make a construction. Okay, we have to make a construction. Simply, if I want to tell you direct formula, I can tell you direct formula. Right? Okay, so the direct formula for this condition is what simple. The resultant vector's magnitude is equals to under root of a squared b squared plus 2ab cos theta. This is a very simple formula. Okay, no need of derivation and direct rule. Okay, if there are two vectors, this is A and this is B, then the resultant vector will be this, like this one. This means one vector, second vector, and the resultant vector like this. Yes, please. Yes, sir. See, any angle. This is simply a triangle law of vector addition. You know the triangle law of vector addition? Okay, no problem. Mikhail, you also know the triangle law of vector addition? Triangle law of vector addition. No. Like if there is one vector in this direction and a second vector in this direction and a third vector, the resultant vector will be this. This is triangle law of vector addition. Sorry? Yeah, trigonometric method. You can say this. Okay, or you can call it triangle law of vector addition. So this is the same formula. Like you can use this one instead of this. And but this formula resultant vector applies everywhere. Any two vector can be added by this. You just remember this. Okay. So this, yes, please. Yeah. So if this is the velocity in this direction, this is the velocity in this direction. The resultant velocity will be this. Okay. If the angle between them is theta. If the angle between them is what? Theta. Okay. Now you will remember this. Okay. Now if I say that there are two velocities, one velocity in the upward direction, the second velocity in this direction. Two velocities we have. Okay. But when the particle was falling downward, or it will be going like this. See, like this. Then by the time when it was just touching the ground, it will have two velocities, right? One velocity will be in this direction, and the one velocity will be in this direction, right? So therefore, if I connect both of them, this will be the resultant velocity, right? So here the angle between both of the vectors are what? Both of the velocities are 90. Isn't it right? Velocity and this velocity both have 90 degree angle. Okay, so if the velocity in the direction of horizon and the velocity in the direction of vertical, both should be added. So if I apply this formula, how should I apply this? So resultant vector, resultant velocity, okay? Velocity resultant will be like this, under root of velocity in the vertical direction square plus velocity in the horizontal direction square plus 2 velocity vertical, velocity horizontal cos 90 degree. Tell me, why did I put 90 degree? The angle between them. You understand that? Okay. If the velocities are more than 90 degree angle, so cos 90, what is the value of cos 90? It should be 0. It should be 0. If it is 0, 0 multiplied by anything is also 0. So this term whole becomes 0. So what is the VR we will get? Under root of AB square plus BX. What is it? What are we doing? You got it? Simply, this is simple. Okay. For this case, especially this case, for not every two vectors, you will use the 90 degree. Okay. Only in case of two velocities are totally. Here it was a 90 degree angle, that is why I used it. This is okay? Okay. So right now, since I have to add two velocities, now first of all, I have to find v in the vertical direction and v in the horizontal direction. Huh? V horizontal will be u cos theta. Huh? 20 cos 35. Okay. Cos 35 or cos 25? you were actually calculating for 35. This was the problem. So V horizontal is remains same. It is what? V horizontal it remains same. It is what? Tell me. 22, sorry, 20 equals, yes. 20 multiplied by cos 25. This velocity always remains in the direction. Okay. Now what about V in the vertical direction? Can you anybody tell me what V will have? Why? In the vertical direction, how did you calculate? Tell me. This should be know that. How did you calculate this? Vertical direction velocity. Huh? Like which formula you used? Yes. V is equal to u plus a. So what is the u took? 0. What is the u took? 0. And when the time came, when it started reaching towards what? See, one more thing we can do here. The displacement, we can do it by the displacement. Let me check it. If they are given the term displacement of use that term or not. Sorry? Why? You can displacement. V is equals to u plus again. What is the u took? 0. Okay. And what is 80? 0.86. Why you use 0.86? Are you sure? But it is still not on the bottom. Just before it. Okay. So what time we should take? Any guess? Same? Zohaib, are you sure? Two components of the velocity. Yeah. Okay. So simply we are taking the same approach. Since we are using v is equal to u plus at, at the top we consider it that u was 0 and the a is minus g, right? And the t we use what? 0.086. Okay. So g's value is what? 9.81. So basically we are getting what? Here. Minus 9.81. 9.81 is the acceleration value, gravitational acceleration number. Yeah, oh, right. Yeah. So it is what? Minus of 9.81 0.81 multiplied by 0.86. Tell me, Fahim, if you are getting this, what is the value you are getting for this? What is this? Minus 8.4. And what would this be? 20 multiplied by cos 25? 18.1? Yes. Okay, now tell this. Velocity resultant just before it's falling. Under root of minus 8.4 square plus 18.1 square. Plus, sir, are you referring this to the last question? Yes, already. Because it will have two velocities, right? Like at the time of falling, just touching before the ground, it will have two velocities. Right now we are adding both of them. What is the velocity, Fareem? Sorry? 19.95. Is the same as we are getting? Everyone? Yes. So 19.95. You can see that exactly 20 meter per second. Okay? So 20 meter per second will be the exact answer, exact, kind of velocity it will have by the time it will fall. Understand that how do we evaluate? So 20 meter per second is answered. Okay. Any doubt regarding this? Range and height also defined? Yes. Should I have this? You're taking out? Finished? Main? Okay, done? Okay. Now, now tell me, one more important thing. We were evaluating time, right? And for what? Range. Okay, range. Now, first of all, tell me, for the time of flight, you want to evaluate the time, right? I told you that. What is the time of flight? The time of flight is the time taken by projectile to get vertical displacement 0. So the vertical displacement should be what? 0. So the S must be what? 0. You understand that? Okay. And tell me, what is the U? U in the direction of initial velocity. U in the direction of is the vertical velocity. U sine theta. Yes. So it should be U sine theta. Alright? Okay. And now tell me, what is the acceleration? That is minus of G. Yeah. So much. Yeah, so which equation we should use? V is equals to U plus AT or S is equals to UT plus half AT square, or we should use 2AS is equals to V square minus U square. Which one you want to use? For calculating time. For evaluating the time. Obviously, S is equals to UT plus half AT square we will use. Okay, so here the time we can evaluate. Okay, very easily. Like how? So S is equals to 0 is equals to U. U's value is what? U sine theta multiplied by T. The T is the time of flight that we will evaluate the times considering this schedule. Okay, plus half of minus G. This is minus G, and what is T squared? So why would you use the first one? See, the first one does not have any displacement. Oh, I have told you the difference. Then what is the time of flight? Time of flight is time taken by projectile. Zero. Yeah, there is no displacement anymore. Even we cannot use this one also because this doesn't have. Okay? Fahim, you're getting it? Okay. So by this situation, we can say that this will become 0 is equals to U sine theta multiplied by T minus half GT squared. Alright, so this equation will go, this side will go like this. So minus U sine theta multiplied by T must be equal to minus of half G multiplied by T squared. Minus and minus become plus. Now tell me the value. What is the U? U is what? 20 multiplied by sine 25. T we want to evaluate. 1 T will be cancelled by this. See, there Here, right? So T will be cancelled like this. This and T gets cancelled. So 1 T will remain here. So is equal to half. And the G, what is the value of G? 9.81 multiplied by 90.
Just minus 9.1.
Huh?
Oh, no, it's not.
Negative got cancelled. Right? So what happened now? What is the value of T? So 20 multiplied by 2 multiplied by sine 25 divided by how much? 9. Hmm? 1.72. This we evaluate to everyone by that formula also. So what you have to do, I'm giving you a very simple approach. Just remember those equations that I told you, like t is equals to 2u sin theta, simply putting the value 2u sin theta over g. In this equation, you directly get this. Then you have to just show like this. Is it simple or not? First of all, by this equation, you will get the answer quickly. If you get the answer quickly, you just have to prove that answer can be obtained like this. Simple. Well, a very idea what I'm saying. The marks cannot be getting, cannot be obtained by this. You cannot obtain the marks by this. What do you have to do? You have to represent in front of them that you have used this any of the equation thoroughly. Mikhail, you got the idea what I'm saying? Mani, this is what I'm talking about. If you want to obtain marks, we have to show full exposure of the formula. Okay, and the exposure of the formula you will use, and finally you will get the same. This is how we need to do it. Okay, shall we go for more question? Okay, I'm running this. I'm running this. Well, I'm running it. Are you noting it down? No. See, for the derivation, how did we obtain that resultant vector is equals to under root a square plus b square plus 2ab cos theta? You have to, take, last class that I have recorded also. In that class, I will send you the link. You can get it. How did we obtain that equation also? You can get also that. If you are still interested in that you're not, able to attend that only class, that the previous class. So I can derive it also, but in the other class, not in this class. Okay? Okay. So yes, the next question that we are doing. Next question. Yes, a projectile is launched from point O at the angle of 20 degrees. Second question. A projectile is launched from point O. Launched from point O. Okay, at angle 22 degrees. Okay, with initial velocity 15 meter per second. With initial velocity 15 meter per second. All right. An inclined plane. Okay. Up an inclined plane. Up an inclined plane. Up an inclined plane. Up an inclined plane that makes an angle 10 degrees with the horizon. Okay. Inclined plane which makes, this is advanced level question, okay, which makes angle 10 degree with horizon. Okay, the projectile hits the inclined plane at point M. The projectile hit the plane, at point M. At point M. So what we need to find? Number A, find the time it takes to hit the inclined plane. Find the time it takes to hit the inclined plane. And the question B, find the distance over. Find distance. Okay, to try it. This is advanced level question. Okay, Mikhail, you understanding it? The language of the question? No. Zohaib?
So we have to find the total incline.
Yes. First of all, you have to find the total incline. So what should be the total incline? 22 plus 10? 32. Are you getting it? What I'm saying? See, this is asking a question like this. Okay, there is a horizon. Okay, with this horizon, there is a plane. Okay, and this plane is inclined at what time? Okay, on this plane, there is another projectile which will fire forward. Okay, okay. So from here, a fired projectile. Okay, and this makes this angle is 22, and this is O. You understand that? What I'm saying? Yes. So total angle it is making 132. Okay, and this falls at a point M. So you have to find what? OM. It's O to M. The range you will find, and the time you will find. Hmm? Yes. From a height. Where is the height? It is launching from the point. Yes. See, a projectile is launched from point O. Does it give a diagram? Huh? No, no diagram is given. Let me check it. No. The similar kind of diagram, see, if I take like this 10 degree, like 10 degree is small, okay. So if I say this is a 10 degree, so it will go like this, right? Here it is a 10 degree, and here it is like this. This is 22 degree, okay? So it will go and it will reach here, right? Here it is a point M. You understand that? See, so it is yes, a projectile launched from point O, angle 32 degree, the initial velocity 15 meters per second, up an inclined plane, which makes a 10 degree with the horizon. The projectile hits the plane at point M, and that point M is also on what? This inclined plane as well. So the intersection to intersection, no, this is not the intersection. Like I'm not talking about this is another projectile. Projectile is only one. Yes, this is the plane. Oh, okay. This is another plane, inclined plane, right? Oh, and this inclined plane is an inclined the horizon. Oh, yeah, yeah, yeah. Yes, please. 1.62. Okay, one observation from 1.62. Check others, please. Yes. Yeah. Check others, please. This is the height. Yeah. It's not wonderful. This is the height. Yeah. So we use the equation to define. You can assume that S equals UT
First one, nothing is good.
For what? Time
By the
displacement. To find displacement, see, it all depends upon your approach, which approach you are taking. First of all, if you find the time, that will be better. Okay.
Yeah.
So if you want to find the time first, the time is what I told you already. That time is what? Simply, it is a what do we call it? Like to make the vertical displacement zero, right? In this case, the vertical displacement is this one. Not like it is hitting somewhere in the horizon. It's not hitting the horizon. It's just hitting the same plane. Just try it. Use your brain. 0.81.
what is that?
Like you are double the time, right? Initially you evaluated the half time. Broken? Looks like it's broken. Yes, please. So what is the answer? Tell me for you. Huh? 1.146. 1.146. Okay. For A, right? It should be in seconds. Yeah. Okay.
There is the answer for the range for distance
20.6 meters. 20.6 meters. Okay, range. What about range?
I do get 1.146.
146. Okay, sorry, 1.146. Yes, the range. What about range, Fahim and Fareed and Maneen? Okay. See, if I say directly the time and time correct, you won't get the thinking approach first. See, there should be different approach in this. And I know that what are you evaluated? You first evaluated half time, right? Then you doubled it. Okay. So if you evaluate the half time first, then you will not get the correct approach. Okay. So let me give you some first good approach, then we will go ahead. Okay. So So 1.146 is what for time? This is correct. Okay, the time is correct. Basically 3.22 distance. Okay, 3.22 is not correct. Okay, is like the range you are talking about, right? Range is not correct. Huh? See, the answer of the range is 15. Okay, 15. Yes. Answer of the range is 15 meters. Any answer nearby to 15 is will be correct.
What's the 20.6 is not correct.
See, the time you evaluated what? Time is what? 1.146, right? Just multiply with the 1.62.
Yeah.
For the range. For the time. 1.62. This is more correct. The answer I am getting is 1.16 seconds, right?
What is it?
Huh? Let me check it first because the answer solution is not there. I've just calculated it by I have to download it first, and I have not a paid version of this website.
So it is line itself, right? Oh, because you didn't count the 73 there.
Yes. See, it is hitting here now.
You didn't count
It is not hitting here. You extra calculated this time. You understand that? Yes. But you put 22 degree. You took the 22 degree, right? Simple. The answer was correct. See, here is the projectile starting here, and it is hitting the plane also. Then which angle should you take for the projection? 22 or 32? 22. That is why the answer is different. Like if you're getting 1.62, it is for total, like hitting something there on the horizon. But it is hitting the plane also. Understand that, Zohaib? Maheen? You understanding it or not? Yeah, yes. So the same thing that 1.0 somewhere nearby 1.16 is correct. Okay. And if you multiply 1.16 with the u cos theta, you got the answer. That is 15 cos 22 degree. Simple. Simple. What about you, Mikhail? 1.14. Yeah, time is correct. And what about the range? Range for range we need to for time multiplied by velocity. So what is time? 1.146. And what is the velocity? 15 multiplied by cos 22 degree. Huh? 13? 15, yes, 15 meter is correct. 9. 9. No. 15.5 is somewhere is correct. 15.9 is somewhere go like exact 16. Huh? Okay. Anyway, next question. Should I give you direct figures? Okay. A projectile is to be launched at 30 degrees so that it falls beyond the pond of length 20 meters. Okay. There is a pond. Okay. The pond has length 20 meters. Okay. A person hits a projectile like at 30 degree he hits it. Okay. And he wants it to land beyond the pond. Okay. See the pond. There is a pond. There is a pond. Okay. This is a pond. This pond is 30. How much? No, 20 meters. Okay. This pond has length about 20 meters. Okay. And a person fires a projectile. Okay. At 30 degree. Okay. So that it, it travels this whole length and it falls here. Okay. What is the range of the values of the initial velocity so that the projectile falls beyond the initial point? Huh?
Can you explain the distance?
20 meters is this. Like the length of the pond is given like 20 meters. Huh?
Length of OM.
It is O, see, OM. In this term here, see, if it is launched from here, okay, with a certain velocity, it is what? It is simply a range, right? From here to here, we are calculating simple range, right? If you want to evaluate the range, we have the velocity in this direction. In this direction, we have a velocity, right? And what should be that velocity? That should be u cos 22 degree, right? Okay, and the velocity in the horizon, we got u cos 22 degree. And the time, we already valued 1.46. So tell me, what is the u?
You should be 50.
15, yes. So for the distance, it should be vh multiplied by 10. So what is u? U it is given here 15 multiplied by cos 22 degree multiplied by time. What is the time? 1.46 seconds. Okay, tell me, what is the distance you are getting? So have you got the answer?
Sir, does it only give the angle and the range?
Angle and the range. By that you have to find what the velocity should be.
You have to find the
Velocity. See, the question is simple. There is a pond, okay? Listen to me. Mel, there is a pond, okay? There is a pond. The pond has length, what, 20 meters? The person wants to throw a stone. He launched that stone at 30 meters. Okay, he wants that the stone should land beyond that pond, okay? This is the condition. If I say this is M, the stone should be land here at M. Alright? To land this stone at M point, what should be its velocity? So that it will fall at the point M only. The simple question I'm asking. Should I write in words or statement? Okay, I'm writing it. Okay. Can I have this previous question? Yes. Okay. So the third question. You are taking third question. Okay. Yes, a projectile is to be launched. Third question. A projectile should be launched. Should be launched at an angle 30 degree. At an angle 30 degree. Okay, so that it falls beyond the point. So that it falls beyond the point. Okay, beyond the point. Beyond the point of length 20 meters. Okay, what is the range? See, what is the range? Question I'm asking. What should be the velocity? Initial velocity. Okay. Initial velocity, so that the projectile, fall beyond the pond. It is a simple question. Isn't it for you? Is it simple or a bad question like complicated? It is simple. Yes. Yes. Zohaib, what happened we have defined? Beyond the pond. Start with you be getting answer as well. You're just getting an expression. Whatever you said, minus 453. In the negative direction, you should hit it. Do you guys any remembrance of one formula that I have told you initially? Yes, that's correct. Exact answer. He just used the third formula, right, for the range. See, I have told you initially that for the range we have a formula u squared sine theta divided by g. First of all, you need to make sure that you are getting that square. So what is u square here? U square must be rg divided by sine, isn't it? Yeah, I will tell you later on. But first, we have to know the answer. What I have told you, use this equation to know the answer first. Thereafter, you need to prove that only. Proving is not a problem. You know, I was also okay. So, you know, there was a book, some separate book there used to be in the CBSE. There was for trigonometry. Okay. In the trigonometry, we have to prove a lot of equations, right? So, if you have the left hand side and right hand side, so you can go take any way to prove at final way to right hand side, right? So simply proving is not an issue. First of all, you have to do it. So what is u squared? RG. RGB R, right? What is R? That is 20. What is G? 9.81. What is sine? Twice of theta. Like 60 degrees should be like 30 degrees of theta, right? So 2 theta is what? 60 degree. So tell me, what is the u square equal? 453. And what is the u? U will be under root of 4. What is the u you got? 21.3 meter per second. There should be range. Okay, sorry, the range of velocity. Okay, so maximum velocity is, like, should be this. Okay, now how we will show? This is the main problem. So let me show you how we will show. So first of all, tell me, you have to consider some quantities. Or you have to consider some quantities. What quantities we should consider? So simply we know that the time of flight, right? We should have know that what is the time of flight. Because range is what velocity to time, right? So time of flight we need to know first. So let projectile reach beyond pond at time t, in time t. So in that condition, I know that we can easily know that the vertical displacement is being 0, right? So in that condition, we will evaluate some time, right? So first of all, we will evaluate some time, and that time will be what, by using equation s is equals to 0, u is equals to u sin theta, a is equals to minus of g. Okay, and what remains t? T we need to evaluate. So by using this formula, see, Mikhail, by using this data, we will know the time first. Okay, and what the time should be? Time will be like this, like 2u sin theta over g, right? This should be the time. All right. Now let it remain the time like this. Okay. Now what about the range? So we know that. We also know that the range. What is the range?
Sir, how do you know if you want to use sine theta or the cosine?
How to use?
Now, how do you know if you want to use sine theta?
Where? Where? See, sine is a vertical component, and cos is a horizontal component. All right. Whenever you are evaluating the vertical thing, like time of flight is decided by vertical. So we will use vertical formula, vertical sign. The vertical velocity we will take. If we are evaluating the horizontal range, then we will take the horizontal velocity, that is u cos theta. So cos is a horizontal component. Sine is a vertical component. So whenever you are evaluating any vertical quantity, you will use vertical component. Whenever you are evaluating horizontal quantity, the horizontal component. Okay, so this is the T we will get. For time of flight, this should be the vertical, right? Because the particle is more like vertical direction and then come down here. So it should be vertical or horizontal y. Vertical. That is why I took you second. You understanding well? Yes. So we know that about the range. What is the range? Range should be what? U cos theta multiplied by time, right? Okay, what is the time given? So range should be what? U cos theta multiplied by time. Time is what? 2u sin theta over g. Isn't it? Okay, can I have this? Remember this calculation. Got 21%. Same answer we will got by this. I'm having this. Now what we will do? Huh? That was the time. So this is the same time that we got. By this equation, by this data, and putting this thing in this second equation. Okay. You got it? The same thing we did. Okay. So this is range, right? Now range we have given what 20 meter. Okay, u we need to evaluate. So what we have given here? U and u multiplied by u square, right? So we got it u squared 2 sin theta multiplied by cos theta divided by g. So g's value we all know that. So what is the u square? So u square is basically what? R g divided by 2 multiplied by sin theta multiplied by cos. Now tell me, u square we want to. What is the value of r? 20. What is the value of g? 9.81 divided by what? 2. What is sin theta? Sin 30 multiplied by cos 30. Evaluate that first. Square theta. 450. Yes, sir. Huh? First game? Okay. So you got it behind. How we will represent? Okay, move. 200? 126. Where? Show me. One. This calculator again. This value see 20 multiplied by 9.1 divided by 2 multiplied by sin 30 is 30 degree multiplied by cos 30. What is 20? Huh? Yes. 200 and 26. Yes. Maybe it's wrong. No. Or maybe you put it like no. This is also correct. It cannot be wrong. U cos theta we know. 2 sin theta multiplied by cos theta. Sin 30 degree cos 30 degree that we do. But here now, what is the main problem? Not stated in 50 degrees that is possible on 20 degree. We took the same value now. So even with this equation, no, even with standard equation, we get it. Okay, anyway, sorry. When I use 200 and who got this 450 plus? Let me check it first here. Huh? 15.05. 15.05 for what? For the U. Okay, so just keep this question. We will be discussing again, okay? Okay? We will discuss the same again, okay? Right now, you just take it simple, okay? Discuss this again.